Assalamualaikum warahmatullahi wabarakatuhu. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial. Today we will start bond valuation model or bond valuation. So firstly we have tried to know what we mean by bond. Actually, bond is a long-term debt instrument issued by a corporation or a government. It is a security that pays a stated amount of interest to its investor or to the investor or to the purchaser period after period until it is finally returned by the issuing company. So it is clear that bond is a security that provide interest to the investor period after period until maturity or finally returned by the company. So before we try to know the bond valuation model, we had to know several terms, core terms of bond valuation model. Firstly, face value, coupon rate or coupon, maturity value, maturity date. These are the several topics which are too much related to the bond valuation model. So firstly we will try to know the face value, the stated value of an asset. In the case of a bond, the face value is usually $1,000 or 1,000 taka. So it is simply face value means the value on a face, as like this is a bond. Here has a value at the top corner of the bond. There has a value, and here has the value. Or whenever you have your taka or money in front of taka, there is a written value. That value is called face value. This value is called face value. And after the end of maturity date, you will receive this 1,000 taka from the company. Then that amount is called maturity value. Maturity value, same. Face value and maturity value is the same. Face value, maturity value is for the end of the maturity period. That means if it's the maturity period is 2 years or 3 years, that is the maturity period, or 10 years, whatever, that is the maturity period. That means after the 10 years this bond would be mature. That is the maturity value. And this bond will provide you a coupon interest rate. That means you purchase 1,000 taka, it will provide you as like 10% rate of interest for the year or semi-annually. So this 10% is called the coupon rate. Coupon rate. This 10% is called coupon rate. And at yearly you will receive from this bond 100 taka. 10% into 1,000. That means you will receive yearly 100 taka. This is called coupon. This is called coupon. This 100 taka is called coupon, and this 10% is called coupon rate, and yearly you receive 100 taka, that is the coupon. If this bond is semi-annually, then you will receive 50 taka and 50 taka. One is June, another is January. So semi-annually, this 50 taka is also called the coupon. Yearly 100 taka or semi-annually 50 taka you will receive from your investment. That's the bond mechanisms, or that's the bonds core terms. One is face value, coupon rate, coupon, maturity value, maturity period. These are the mostly important things which are related to the bond. After that, we will see a very special type of bonds. You can call it the perpetual bond, which never mature. The first place to start determining the value of bonds is with a unique class of bonds that never matures. These are indeed rare, but they help illustrate the valuation technique in its simplest form. Originally issued by Great Britain after Napoleonic Wars to consolidate debt issues, the British Consul is one such examples. The British Consul, short form consolidate annuities, or you can call it the Consul bond or British Consul bond. This bond carries the obligations of British government to pay a fixed interest payment in property. A bond that never matured, a perpetuity in the form of a bond. The present value of a perpetual bond would simply be equal to the capitalized value of an infinite stream of interest payments. If a bond promises a fixed annual payment of I forever, its present or intrinsic value V at the investor's required rate of return for this date issues KD is in the form of in here V equal to interest payment divided by interest rate. That is the formula for finding the value of perpetual bond. V equal to 1 by KD, that means required rate of return, or K, or someone call it R, no problem. What is the name of this? That is not a big problem. So in here has an example. The present value of perpetual bond is simply the periodic interest payment divided by the appropriate discount rate per period. So this is the example. Suppose you could buy a bond that paid $50 in a year forever. Assume that your required rate of return of the bond is 12%. Then what would be its the intrinsic value, or what would be its present value? So you can calculate it easily. That is 50 divided by required rate of return is 12%. That means 0.12. Then the result would be the value of the bond, that is 416.67. This is the maximum amount that you would be willing to pay for this bond. If the market price is greater than this amount, however, you would not want to buy it. So we know that the rules for purchasing bonds is that if the intrinsic value is lower than market value, then if the market price is greater than this amount or greater than the intrinsic value, you cannot purchase this type of bond, then you would sell this bond. So rules is that if the market price is greater than its intrinsic value, then you can sell, not buy. If the market value is less than intrinsic value, then you can buy. So if the market value is lower than the intrinsic value or present value, then you can buy this bond. This is the rules of purchase of bond in the capital market. Now we will see the bond values with the finite maturity. Still we are discussing about infinite maturity, that is infinite, that means never ends. Now we are going to discuss with the finite maturity. So here we will see the non-zero coupon bonds and zero coupon bond. Whereas the finite maturity, it should be non-zero coupon bond and zero coupon bond. At first we will see non-zero coupon bond. If a bond has a finite maturity, then we must consider not only the interest stream but also the terminal or maturity value in valuing the bond. The valuation equation for such a bond that pays interest at the end of each year, that should be in this model interest for the several periods, and lastly maturity value. Then this is come to the present value. So these should be the this interest payment or coupon payment should be equal for the each year. That's why that is the annuity. So these portions are annuity, and this is the end of maturity periods value. So that should be count as a present value, and this portion should be the present value annuity. Present value annuity. So it is clear that the formula should summation 1 divided by 1 plus kd power t, I means interest payment, plus mv divided by 1 plus kd power n. So you can do this formula with the help of financial table. You can do this problem with the help of financial table. So it is here the financial table. You can have this table in this way. I, that means interest into PVIFA, that is present value interest factor annuity. KD means interest rate and the number of periods, plus MB maturity value into present value interest factor, KD interest, and N, that means if we see our table where has this value, then we can get our value. So this is the formula, or if you use this formula, or if you use this formula, whatever you like. This is the tabular method, and this is the tabular method, and this is the calculator method. So whatever you like, you can do the solving your problem. So remember that I coupon or coupon payment, PVIFA, present interest factor annuity, KD your required rate of return, N number of periods plus MB maturity value, PVIF present value interest factor, KD means required rate of return, N number of period. See, here has an example. We might wish to determine the value of 1000 par value bond with a 10% coupon and 9 years to maturity. That means this bond has a maturity period of 9 years to maturity. That means it still have the period of 9 years. The coupon rate corresponded to interest payments of 100, and if our required rate of return is 12%. So here as everything we have maturity value, that means 1000 taka our maturity value, 10% coupon, 10% coupon, that means it provides 100 taka per year. 10% into 1000, that means 100 taka per year, and its required rate of return is K, means required rate of return is 12%. Then what would be its value of this share, sorry, of this bond? What would be the value of this bond? So if you put down this value in this way, I means interest payment, it should be 100, then PVIFA present value interest factor, KD interest, that means 12%, N number of periods to maturity, that means N should be 9 years, 9 years to maturity, that means 9. Then MB maturity value 1000, PVIF present value interest factor 12% and 9 years. So now if you see the value in our financial table, then we can see PVIFA table, PVIFA 12%, 9 present value factor for an ordinary annuity, PVIFA present value interest factor annuity has said 12%, 9 years, 12%, 9 years. So this here is the value 12%, 9 year, then corresponding value 12% and 9 year. This is the corresponding value 5.3282, 5.3282, 5.3282, 100 into 5.3282. Then we will see 1000 PVIF 12%, 9 year, that means should be table present value interest factor, present value factor for a single amount, for a single future amount, that means PVIF here said 12%, 9 year. So these are the corresponding value 0.3606, 3606. So then if we multiply and summation of this value, then our value should be 893.80. So the value of this share bond is now, the value of this bond is now 893.80. Then we will see if the appropriate discount rate is 12% instead of 8% instead of 12%, then valuation should what would be the valuations? So there has the 12% interest, and now we have to calculate for 8% interest. So if we put down these equations with the value, then interest should be 1000. Value of this share of this bond is 1124.70. Why this has 1124.70 taka? Its required rate of return is 8%, and whereas our required rate of return is 12%, then the value is 893.80. So that is our required rate of return is 12%. Our required rate of return is 12%. Here our required rate of return is 8%, appropriate discount rate. So here we will see this bond is selling more than its par value. So that is the premium bond. Premium. It is selling in premium, and it is selling in discounted, because our required rate of return is 12%, but in this bond we are getting only 100, but our required return should be per year 120. So that's why this should be sell at discount in the capital market. But here has 8% required rate, that means per year 100 taka, 80 taka, but this bond will provide you 100 taka. That's why it is selling is premium. So in this case, present value of bond is excess of 1000 par value, because the required rate of return is less than the coupon rate. So that's the case. This bond is selling in the market in excess of its par value, because its required rate of return is less than the coupon rate. Investors would be willing to pay a premium to buy this bond. In the previous cases, required rate of return was greater than the coupon rate. As a result, the bond has a present value less than its par value. Investors would be willing to buy this bond only if it is sold as a discount from the par value. Now, if the required rate of return is equal to the coupon rate, the bond has a present value of its equal to 1000. More will be said about this concept shortly when we discuss the behavior of bond prices. Now we will see zero coupon bond. That means the bond which is not paying any kind of coupon, that is zero coupon bond. A bond that pays no interest but sells at a deep discount from its face value. It provides compensation to investors in the form of price appreciation. That is the zero coupon bond. A zero coupon bond makes no periodic interest payments, but instead is sold at a deep discount from its face value. Why? So why buy a bond that pays no interest? The answer lies in fact that the buyer of such a bond doesn't receive a return. This return consists of the gradual increases or appreciation in the value of the security from original below face value purchase price until it redeemed at face value on its maturity date. Such as you hold a bond whose face value is 1000, but this is zero coupon bond. This bond will not pay you interest its maturity period, then you have to purchase that bond in 750 taka and hold it for the maturity date. At the maturity period you will receive 1000 taka, that is the face value or maturity value, and this between 250 taka is your profit for holding this zero coupon bond for a period. That is your return from this bond. Now you will see the valuation equation for a zero coupon bond is a truncated versions of the use of a normal interest paying bond. The present value of interest payments component is left off, and we left the valuation should be in this way: MV equal to PVIF KD into N. Simply that is the simple equation: V equal to MV divided by maturity value divided by 1 plus KD power N. Here as an examples. Suppose the Hispanicia Enterprise issue a zero coupon bond having 10% 10-year maturity and 1000 face value. If your record rate of return is 12%, then the value should be using the table. You can get this table from your Google Classroom, MKA Classroom. We have uploaded financial tables, then you can download it from there. So present value interest factor of a single payment 10% 10 period and future value at 12% is in this way you can determine this value. So PVIF 12% 12% 10 year, this is the value. If you could purchase this bond for 322 and redeem it 10 year later for 1000, your initial investment would thus provide you with 12% compound annual rate of return. Here is another option, that is the semi-annual compounding of interest. Although some bonds typically issued in European markets make interest payments once a year, most bonds issued in United States pay interest twice a year. As a result, it is necessary to modify our bond valuation equations or models. Whereas compounding twice a year. So it is a very simple I divided by 2 PVIF KD divided by 2 and 2 into N plus MV PVIF KD divided by 2 and 2 into N. So that is our formula, modified formula. That means whenever semi-annually payment is arising, then we will use this formula in that way. KD is a nominal annual required rate of return, and I is the semi-annual coupon payment, 2n number of semi-annual periods until maturity. So here is an illustration. 10% coupon bonds of US Velvet corporations has the 12% 12 year to maturity, and our nominal annual required rate of return is 12%, and the value should be in this way. So here is the 10% coupon. 10% coupons means 100 taka per year. So it should be 50. That is I divided by 2 should be 50. There is the 50 and KD divided by 2. Here is 14%. 14% divided by 14%. It should be divided by 2. That is 7%. That is 7%. And 12 year to maturity. 12 year to maturity. That means 2 into n. 2 into n. 2 into n. That means 2 into 12. That is 24 as our value. So if we find this value from our table, then the value is 770.45 taka. 770 টাকা for our share bond value, for our bond value. This all about today. Stay home, stay safe. Assalamualaikum warahmatullahi wabarakatuhu.